This is question 16 of the Natural Sciences Admissions Assessment specimen paper. And in this question we have a design which is set up by joining the points which are 1/3 of the line of the way along the sides of a square. So we have then a second square as shown, and we're going to keep repeating this process so we get squares within squares within squares. And we want to calculate the area of the fourth square here as a fraction of the original square. So we're going to do this two ways. The first way is a lot longer, but you should be able to do it regardless of what you notice about what's going on. The second way, you're going to have to notice a little trick which makes it a lot shorter. So let's first go through the first way. So we're just going to call the length of this side of the square here 1. When we say WLOG, this means without loss of generality. And what that means is that it doesn't matter what we call this. We could call it X, but that would just end up with things a bit more complicated. So to make things nice and simple, we're going to call it 1. So this means that because we have the points 1/3 of the way along the side of the square, this is 1/3, this is 2/3, this is 1/3 because it's the same as here, and we're going to call the side here X. So now can you try and work out X by using a formula which links these three sides? So the formula you should have thought of is Pythagoras' theorem, which says that if we square these two sides and add them together, we get x squared as such. And so we know that x is going to be √5/3. So now we've gotten rid of the outside square here, and we're just focusing on the three squares remaining. So we worked out this side x, so this is x now. So now we're going to do the same thing again. We know that x is √5/3, and so we can use Pythagoras again, because we know that this side is √5/3 times 2/3, and this side is √5/3 times 1/3, because of the 1/3 to 2/3 ratio we have here. So we get this, and we have that y squared, which is our new length here, is equal to 2√5/9 squared plus √5/9 squared. And when we work this out, we get that √5 is equal to the square root of 25/81, which is 5/9. So now let's do the same thing again for the smaller square. So now we've taken away this outside square and we're focusing on what we have left. So this length here becomes this length here, which is y. So we know that y is equal to 5/9, so we can find these length and this length by doing 2/3 times 5/9 and 1/3 times 5/9. So we get that this is 10/27 and this is 5/27, and we want to find its z. So let's just do exactly what we did before, use Pythagoras to get that z squared is this side squared plus this side squared, which simplifies down to z squared is equal to 125/27 squared. Now we want the area of the small square as a fraction of the area of the original square, so we're going to do area small square over the original square. So we have 125/27 squared, because the area of the original square is just 1 squared, which is 1, which is why 1 was a nice number to pick. So we get this as our answer, which is 125/729, so our answer is C. So now let's have a look at a slightly slicker method. So we've got the same square as we have before, and we've again said that this length is 1, so this is 2/3 and 1/3, and we've labelled on x as before. So we're going to start in exactly the same way. We're going to use Pythagoras to find x. So x is equal to the square root of 5/9. So the area of the square is going to be, of the second square, so this square here, is going to be 5/9 square rooted, but then squared to give us the area, so it's just 5/9. Now, the thing we're going to notice is a geometric series, and this is going to link up the areas so that we don't need to work out each area as we go along. We can just work out one term, which is the term we need, and that's going to save us a lot of labour-intensive calculations. So we've suggested that we might see a geometric series. Could you work out what the value of A, the numerical initial value, and the ratio will be? Well, A is going to be 1 because that's our initial, which is just 1 squared, our area, and our ratio between the different terms is 5/9. So for the fourth term, for the fourth square, which is what we want to try and find, the term is AR³, and when we substitute in A is 1 and R is 5/9, we should get 5/9³, so 125/729, which gives us exactly the same answer as what we had before. So it's really important to notice there is a quicker way of doing this question, which we've shown you here. So you could do it the first way, but in the exam you're going to be under a lot of time pressure at times. So to notice something like the geometric series will just massively reduce the amount of work you're having to do. If you get a question where you feel like you keep having to iterate the same step over and again to find the answer, so it's almost like we're finding the fourth term here, have a look out and see if you can notice links between each term so that you don't have to work out all the terms separately.